Okay, well, do you remember this thing? It's been a few days. It's a workhorse. It's a Conrad Johnson MV60 and pretty modernistic looking. Don't have it plugged in. Nice power switch. The customer said it was working, and then I think he lost the light in the front possibly. The tube's still light, he says. Now the customer does have this top loose. So there it looks like the drivers, pre-drivers, and output tubes. I do believe he mentioned checking these fuses. Three-quarter amp fuse. So let me get a meter set up real quick. And that one is good. It's a 3/4 amp. Okay, it's not a push and turn, it's a screw in. Okay, that clarifies a lot of stuff. And that fuse is good as well. It's a BBS 3/4, 600 volt Busman. Make sure they're nice and tight. And I guess we can go ahead and apply power to this and watch the meter and see what it has to say. Let me get some speakers connected, because I know tube amps, you don't want to run them without speakers actually connected. So I think I'll connect the dummy load and speakers and we'll go from there. One moment. Well, I had a second thought. Let's go ahead and pop the bottom off of this thing and just see if we can take a look at the circuit board inside. And it appears that I have to remove the sides. There's a couple screws right there, as well as one in the front here and one all the way in the back. So let's get those off. We'll get the bottom off and just take a look inside real quick and see if I see anything that is standing out like a sore thumb. Okay, bottom is off. There is the board. And as I recall last time, that fuse right there was blown. 4 amp slow blow. Let's go ahead and recheck it. My cap's been running hot. Have to ESR that baby, see what it says. And note, this fuse is not blown this time. So definitely something else going on with this unit. It is odd how much that has shrunk down, even though it's on the bottom of the board. Wonder if that's got something to do with it. Well, let me do a little bit more investigation and we'll move forward from there. One moment. So then I'd go ahead and ESR that capacitor. That does not look too healthy. And I get an ESR of 0.34 ohms, which isn't that bad. I'm not sure what the value is. It is a 16 volt capacitor, I do believe, but I can't quite make out the value because there's a big resistor in the way. It looks like a 4700 microfarad cap, but I took my meter off camera here and I just did an ohm check across the capacitor and it shows it's 1 ohm. And then with the leads shorted out together here, I get 0.2, so that would be about 0.8 ohms. Is the capacitor just defective? Did it get too hot? Or is it connected to the filaments on all these tubes? I think I'm going to go ahead and pop all the tubes out of it and recheck that capacitor and see if it shows shorted again. I may have to actually pull the circuit board out of this, which it looks like it comes out fairly easily. All the leads look like they're long enough that you could just flip the whole circuit board up and out. So let me go ahead and mark all these tubes to get them back in the same spot, and we'll give it another ohm reading across that capacitor just to see if it might be the filament. I doubt that it is. Normally they use an AC filament not a DC filament. But let me go ahead and get all the tubes disconnected and we will move forward. One moment. Okay, I've got all the tubes marked. I just put a little Sharpie dot on one and two Sharpie dots on two, and then 3, 4, 5, 6, 7, and 8. And I assume these are on the tubes to reduce microphonics, possibly. Yeah, okay, let's get these tubes out of here, and I'm going to put them somewhere safe, and we'll move forward. One moment. Okay, tubes are out. Let's flip this thing back over, and we'll do another ohm reading on it. And it is charging, so the capacitor is not shorted. So this has got to be somewhere in series with the tube filament circuit. So yeah, very good. Just for the heck of it, let's go ahead and check the ESR of that guy with everything out of circuit now. It was 0.3 ohms previously. Now it's 0.6 ohms. Just ever so slightly high for a 4700 at 16. I don't think I have anything that large. Let me see. I've got 4700s at 6.3 only. So I would have to order a capacitor. So let's just check one of the 4700s at 6.3. And I get 0.02 ohms on that one. And so I really think that this one should be in the 0.0 something range. So it is a little bit high, measuring in the 0.6 range. I'd expect to see that out of maybe a 100 microfarad capacitor. I'd like to see half an ohm or less on a 100. So it is definitely bad. It's going to need to be replaced. But I'm going to have to put the tubes back in this thing and fire it up and see what it does. One moment. Okay, so I've got the tubes back in the unit. I have your big dummy load connected. That's a 8 ohm per channel, 100 watt dummy load. And then these are attenuated outputs through like a 100 ohm resistor, something like that. So I'm going to turn the voltage all the way down, power this thing on, and ramp up the voltage. And I get no load, so that means the power switch must be in the off position, so I just switched it. And I do see current coming up now. We should be at about 120 volts there. And I don't have an indicator on the front of the unit at all, and that actually comes from that capacitor. Now, I thought the customer said that the tubes were lighting, but I'm not seeing anything in the audio output tubes whatsoever. So I think we need to investigate why I'm not seeing any kind of filament glowing in these guys anywhere, even in the driver tubes. I have a little excess cat hair on that one. But no, I'm not seeing anything. So, watching the current, it is actually climbing. So we're at about 1 amp, so 120 watts, and it's still climbing. I'm going to shut it off. And then we'll probably have to pop the tubes back out of it and investigate what might be going on, why we have no filament voltage, and especially why we do not have a red light on the front of the unit. One moment. Okay, so I've got my voltmeter in the AC volt range, and I do believe that these two large wires right here that are white and then white with a red tracer are the AC output of the transformer, and it does go through that fuse. So I want to go ahead. I have the unit down to about 100 volts right now. I don't want to give it full voltage right now. We'll power this thing back on, and I just want to see if I get an AC voltage, 5.3 and 5.4 volts. So why do I not have voltage on this capacitor right there. And I do believe the rectifier diodes live up under this neighborhood right here. Let's go ahead and remove power. AC power has been disconnected. So I know I've got about 6 volts AC coming into this. After rectification and filtering, I should have at least 6 volts of AC. I'm suspecting we got probably either one or more defective diodes down here, the rectifier diodes. I really don't want to have to start unsoldering stuff up here on the top of the board, but it would be helpful if I could lift one lead of the transformer. Oh, you know what? Duh. Dummars. Here. Do that. Okay. One lead of the transformer has been lifted now, so we can do diode checks. Let me zoom in just a little tiny bit here, and hopefully the focus will stay focused. I will put it in the auto magical, and we will achieve critical focus, and we'll put it back in manual at that point. So let's go ahead and check these diodes. We'll go to the diode range here on the meter. Hopefully you can see that. I think you can. And so it appears, I'm not sure which is the cathode and which is the anode. Okay, so I get 787 forward voltage on that guy and 466 on that one. Wow. Okay, that's going to be a problem. Now the other two diodes live underneath this capacitor and they run from side to side. So this should be, let's see, I think that's going to be the wrong polarity. 506, 994, 465, and 790. Why such a discrepancy? I think we might have two failed diodes, because I should get 465 in both directions, or on both of these test points. Yeah, there's something going on with those diodes. Well, I'm going to have to pull the board out of this unit and find out what is going on, and hopefully find some suitable replacement diodes for this unit. Well, let's get the tubes back out of this thing and get this board out. One moment. Okay, well, the board does definitely come out of this unit. It's not going to stay put, that's for sure, but I'm suspecting that these diodes right here have failed, so I'll have to go ahead and get those unsoldered. Let me get a good zoom-in view on those guys. Can we make any numbers out on it? I believe I have it in the manual focus. We'll put it back in auto magical. G1752. G1752, it does look like, is the part number on those four diodes. They've definitely been running hot, so I know what the polarity is. I have video proof of it. I will need to unsolder the capacitor that I think is those two tabs, possibly right there. We'll get the cap out of the way, get the zip tie cut on it. There's the zip tie that holds the capacitor down, and get this guy out of the circuit. Get these four diodes out, check them individually on the MK168 and see what they have to say. One moment. Well, that didn't go out good. Didn't have it on camera, but there I have the capacitor out of the circuit. I'm sorry I was zoomed in so much for that. Well, let me get the big tip on the solder sucker. We'll get these four diodes out of the board and try to measure them out of circuit. One moment. Okay, all 4 diodes are off of the board, and I still have some solder that needs to be sucked up right here, it looks like. I don't like these pads. They're really not sticking to the board too terribly good. You think when you pay this much for an amplifier that they would use a little bit better quality circuit boards, but of course these things are they have a lot of heat buildup, so maybe it looks good on paper, but after 5 or 10 or plus more years, the traces may come off the board because of heat cycling. But okay, got the diodes out. Let me get the MK168 out and we'll test all 4 diodes. One moment. Okay, let's make sure we can read this. Yes, it looks good. I do not have a part connected at the moment, so it's going to say no part or damaged or unknown. So I do have 1 diode connected. That's not a good sign. I should have answers by now. It does not know what that one is. Second diode testing. It does know that's a diode. 595 millivolt forward drop. And then there's that one in the circuit. Third one. It knows that's a diode, 565 millivolt. And no capacitance on that one, 0 nanofarads. And then this will be the last one. No unknown or damaged part. So it tells me that 2 of the 4 diodes are defective. Very, very interesting. How do they test on an ohm meter? Just a regular old fluke. Go to the diode range. Hopefully you can see that. So we're going to go anode, red, cathode. So it does test like a diode. But the voltage is way too high, 0.8 volts. That is way too high. I want to see 0.6, 0.5. Up, 478. That one is good. $493, $492. That one is good. And then this one should be open as well. Ooh, that one's actually reading good. So interesting. The MK168 said I had 2 that were defective. The fluke meter says I have 1 that is defective. So let me try to figure out what these numbers are. We read them off previously. So GI1752, and then over here is 0036C. Well, let me see if I can find replacements. They're probably either 4 amp or 8 amp general purpose diodes because they run at 60 hertz. I don't think I have anything like that. I might be able to parallel a bunch of 2.5 amp diodes together. But still, I think they need a proper replacement. So let me see what I can find. One moment. Okay, well, through Vichy, I did find the GI752. High current axial plastic rectifier. And according to these specs, forward amperage is 6 amps. There's some other stuff. Case, blah, blah, blah. So a 752 is a 200 volt rated capacitor. Why they would use that in a 6-volt circuit when they could get away with the 750. Maybe they had a couple extra ones laying around. So I'm going to do what I can do and see if I can find some replacement 752 diodes. And that should get this thing working once again. So I think I'm going to end it as part 1 right here. Hopefully I can find some replacements for this customer. I'm pretty sure the customer is going to approve the estimate on this unit, but no one knows. Not even me. Only the customer knows. So anyhow, that is going to be it on the Conrad Johnson MV60. Let me try to get this thing a little bit back into view for you guys. And that's about as far as I can pull it. So we'll go back to auto magical exposure, and we'll go back to auto magical focus, and we'll zoom in on where the diodes actually came out. There we go. All right, remember, you can follow me on social media, Facebook, Instagram, Twitter, or X at NorCal715. You can email me, NorCal715videos@gmail.com. As of right now, it is the first part of 2026. If you want to contact me, please just leave me a comment in one of the videos. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this video. I really, really appreciate it. Everyone have a great day. Once again, thank you so much for watching. Bye-bye. And I thought, just because this one cap's been running hot, I'm not sure what got it that color. I went ahead and unsoldered all 3 of these caps. They're probably some kind of polystyrene metal film type capacitor. And I thought I'd go ahead and measure the value. All it says is SN150NJ, so I can imagine 150 nanofarads or 0.15 microfarads. And they're rated at 600 volts. So let's go ahead and give it a test. I do have one side unsoldered here, and it reads 148 nanofarads. So it is a 150 nanofarad or a 0.15 microfarad capacitor times 3. So I think I'm going to go ahead and try to find some replacement capacitors for those. Probably like I said, metallized polypropylene film type capacitors. And I'm sure they're just using them as bypass capacitors. But I did measure all 3 of them out of circuit. They are all 3 unsoldered on one end, so I can get an accurate reading. So like I said, just because this one has been running so hot, it's actually starting to unpeel the wrapper that's around the outside of it. So I think I will go ahead and replace those as well. Give this thing a nice little tune-up since I have it this far apart already. Okay, well, just an addendum. Everyone, thanks for watching. I really appreciate it. Have a great day. Bye-bye.